There we go. All right, so let's take a look at part two. Part two, during grand festivals, balloons are arranged at perfectly equal intervals in the shape of a circle. Fluff bolts are fired in such a way that they fly perfectly through the center of this circle. If the fluff bolt pops the first balloon and continues flying, it can pop the balloon directly opposite, but only if the number of balloons before the shot was even. Otherwise, it flies between the two balloons directly opposite without popping them. After each shot, the balloons are rearranged in perfectly equal intervals in a circular shape. The task still involves providing the number of fluff bolts needed to destroy all the balloons. However, the number of balloons is quite large, so instead of developing a full scheme, only a fragment is provided, which needs to be repeated 100 times. The circle should be constructed from the resulting list of balloons. Okay, the last thing to explain is at which balloon the next fluff bolt should be shot. If we number each balloon on the list in sequential order 1, 2, 3, and so on, then the next fluff bolt is always shot at the balloon with the lowest number. Okay. So if we take this and repeat it 5 times instead of 100 times, then we get this sequence here, and we're going to show, okay. So this red shot pops the green balloon, but doesn't keep going. The green shot pops the green balloon, keeps going, but there's an odd number of entries, and so it passes between these two balloons. So we don't have to worry about it. So if it's odd, we just pop the first one regardless. If it's even, and we pop the first one, and it's the same color, then we pop the one in the middle here, halfway down. Okay. I understand. And we keep going until we pop all the balloons, and we say how many balloons are popped, and this says 14. So then we have a longer example with 10, 50, and 100, and we have the answers for 10, 50, and 100. Okay. How do we want to approach this? Because now we're moving from the middle, and repeating 100 times. Well, I don't know. Repeating 100 times isn't okay. The problem is I don't think I can just do what I did before and just maintain a pointer to how many we popped, because we do need to figure out where the midpoint is. We don't need to know the color of the midpoint. We just need to know where it is. But we do need to keep track of it because it's going to eventually shift to the front. If we haven't popped very many, I mean, right? Eventually, it might work its way to the front. So we still need to keep track of everything. I'm trying to think, can I do this with 2 pointers? And I don't think I can. I think it would be hard to do with 2 pointers. Let's try just doing it with a vec and pulling the entries out of the vec. What was that? It was 256 bytes instead of 200 bytes. Okay, so it's a little bit longer, but not that much longer. And if we multiply it by 100, it's still not that bad. But I'm guessing that part 3 is going to be, okay, now do it 1,000,000 or something. And then we're going to have to come up with a clever MV documents, everybody codes. Oh, downloads. Everybody codes into input. Yeah. Okay. So it's just nothing special. Let's read it in. We can reuse this sequence, right? Because it's still doing an RGB sequence. And what are we looking for? How it's still how many fluff bolts? Yeah. Yeah, so it's still doing RGB, RGB, RGB. Okay. So this sequence here is actually something we can just make a const. and then change this. Right, and that way it'll be used everywhere. And now, okay, we don't want to just do a regular shoot. We want to do a double shot, a circle shot, right? Self, and then what fluff bolt char. What we can do, we can pop the front one because we're always going to pop the front one. And if before we pop it, it was even, so we can do this. We could say let len is equal to self q len, right? And we can say pop the first one, which is going to be self q. Yeah, this is not so good. We should probably use a vecdeck because we're removing the first one. Oh no, we want to say if len mod 2 is equal to 0. We want to remove the middle one first. If the first one, self q of 0 is equal to fluff bolt and len mod 2 is 0, then we're going to remove the middle one. So self q remove len divided by 2. And then we always remove the first one, self q remove 0. Right? And that's a circle shot. We do need to extend this. Okay, we'll use the test business here, right? Balloon Q. It's no longer a Q now, right? New of this, and it's basically this loop again, except instead of saying shoot, we're going to say circle shoot, circle shot. Let's be consistent here. We do need to repeat it. Okay, so we have the repetition here 10 times. How do we want to do that? We could say balloons Q, I don't know, balloon, yeah, Q repeat. Is there a repeat? Creates a vector by copying a slice n times. Okay, so we want to say balloons Q equal. We should put this inside. This should be in here. So fn extend circle self, and it should just be self q equals self q repeat how many times? Right. Balloons extend circle by 10. Okay. So if I hit run, we get 304. Is that right? It is. And so if we extend it by 50, 1464, perfect. And by 100, 2955. Okay, so I think we're ready to test it out with our input. 16140. Oh, that's a glitch in the Quactrix. All right, so it works fine for this input and it fails on my input. Oh, because I made the mistake that I'm trying not to make anymore. All right, here we go. 21442. But I have to wait a little bit of time. Yeah, so I think what part 3 is going to be is do this. It's going to be a much longer thing, and it's going to be do it a million times. And so this is going to end up taking way too long to run because of all of the. When you remove from the front, what we could do is just reverse it. When you remove from the front, it has to shift everything down because it's just a vec. When you remove from the middle, it has to shift half of it down. So it's not a pleasant performance experience. So let's submit this one. I've got that quack power. Nice. 49th place. I didn't check my progress after part 2. Although this has, oh, now we have balloons going up as well as coins going down. What happens if they collide? Or they just pass through each other? I'm curious. Oh no, they pop. Look at that. Okay.